I'm Alex, and I work with the New York Power Authority. In the last video, we learned how to build a hydroponic system using recycled materials. Today, we're going to be investigating the question, how can plants be used to generate electricity? What do you think you need to light the light bulb in a flashlight? That's right, you need an electrical source. For this flashlight, the electrical source is coming from a battery. Batteries are one way we can power devices, and they are convenient because they allow us to run and power devices without being attached to a power cord. But what is a battery, and how does it work? A battery is like a portable power pack. It stores electrical energy in chemical form. Batteries have three parts: an anode, or the negative end, a cathode, or the positive end, and if you were to open a battery and look inside, you would find an electrolyte, or a solution made up of different chemicals. The electrolyte separates the anode and cathode and allows for the flow of electrical charge. When a battery is connected to a device, like a light bulb, a series of chemical reactions take place. The reaction at the anode generates extra electrons which want to move to the positive end of the battery. This flow of electrons is what generates the electricity to power the light bulb. Let's take a look at what materials you'll need for this investigation. A potato, tomato, or a lime, or anything else you could grow. A knife, 2 pennies, 2 zinc-plated nails, 3 pieces of copper wire, and a very small light bulb or LED light. Once you have all of your materials, we can set up the investigation. I'm going to start with the potato. If you want to try this on your own, make sure you ask a parent or guardian to help. The first thing you need to do is cut the potato in half. Next, cut a small slit in each half, large enough to hold a penny. Then, wrap some copper wire around each penny a few times. Be sure to use a different piece of wire for each penny. Stick the pennies in the slits you cut into the potato halves. Next, wrap some of the third copper wire around one of the zinc-plated nails and stick the nail into one of the potato halves. Take the wire connected to the penny in the half of the potato with the nail and wrap some of it around the second nail. Stick that second nail into the other half of the potato. Next, connect the 2 loose ends of the copper wires to the small LED light. Be careful when handling the wires because there is a small electric charge running through the wires. Hydrogen gas may also be a byproduct of the chemical reactions in the potato, so don't perform the experiment near open flames or a strong source of heat. If your LED light is very dim or does not seem to be lighting up after you complete the circuit, try adding an additional piece of potato to the series. In this potato battery, the zinc nail is the anode, or negative end, and the copper penny is the cathode, or the positive end. Zinc and copper react with each other, producing chemical energy. The reaction at the anode generates extra electrons, which want to move towards the positive end of the battery, or the penny. The potato is the buffer or electrolyte between the two metals. When the 2 copper wires are attached to the small LED light, it completes the electrical circuit, delivering the power to the LED light and turning it on. If you want to continue investigating, you can try using other metals, such as dimes, nickels, and quarters, as the anode and cathode. You can also try using other fruits and vegetables. Which combinations work best? Which don't work at all? Now that you've seen how plants can be used to generate electricity, check out the next video in this series where Matt will talk about how we, humans, use energy at home and in our greenhouse classrooms. We'll also talk about how our energy use impacts our planet. See you next time!